Hi-ho there, friends. Today we're going to solve equations, literal equations, and linear inequalities. We did some graphing of these last time you heard me talk, depending on what your life schedule was. But today we're just going to solve basic equations. Some of you might be able to blow right through this and be great at it. Some of you just need to take time to make sure you know the little steps well enough so that you can practice some of this stuff on your own. So let's just jump right into it. Whenever you're solving an equation, your goal is to get the letter, the variable, all by itself and all the numbers on the other side of the equal sign. It doesn't matter which side the letter ends up on and which side the numbers end up on, but they're supposed to be on different sides of the equal sign. An equation is like a scale, like an old school scale that's balanced. And the equal sign represents that both sides, even though they may have different amount of things on it, both sides are balanced and equal. If I take something away from one side, then I need to make sure I take away the same amount from the opposite side in order to keep them balanced. Same as if I add something. If I add a new block to one side, then I need to make sure I add the same amount to the other side in order to keep them equal. Equations work the exact same way. So, for example 1, if I want to get x by itself, that means I have to get rid of the 22. In order to move the 22 from one side of the equal sign to the other side of the equal sign, I have to make it disappear. To make it disappear, I do the opposite of what's keeping it there. Now what I mean by that is, if I see that it's plus 22, the opposite is minus 22. That way, 22 minus 22 subtracts out to be 0. But if I take something away from one side, in order to keep this balanced, I must also do it to the other side. And this is where you may need to use your calculator, which is totally fine. You can use your adding machine, calculator, you can brain, whatever you need to do 4 minus 22. And then when you get your answer, you just write it down, bring down the equal sign, and then we're going to keep the negative 3x exactly the way it was. Please be careful, my friends, to bring the negative down with the 3, because it is a negative 3x. The next piece, I need to get the x alone, so I have to pull the negative 3 away from the x. To separate those two, I have to use the opposite operation. Just like the plus 22 needed a negative 22 so that it would cancel, here this is negative 3 times x, and the opposite of multiplication would be to divide. So I'm going to divide by the negative 3 on both sides in order to keep it balanced. Any number, negative 3 divided by negative 3, any number divided by itself cancels out to be 1. So technically this turns into a 1x. Negative 18 divided by negative 3, go to your calculator if you need. Negative divided by negative is a positive. 18 divided by 3 is 6. So 1x is equal to 6, which is the same thing as saying as x equals 6. Example 2 here, there are some parentheses involved, and if there are parentheses, we will use the distributive property. 5 times x equals 5x. 5 times negative 16 is negative 80. Now, if you can't do that in your head, then that's why you have the calculator, negative 16 times 5. The subtraction sign in front of the 16 is telling us that it is a negative 16. So when you type it into your calculator, you can use negative 16 times 5. On the other side of the equal sign, on the left, I didn't change anything, didn't do anything to them, so I bring them down unchanged. Now in this example, we have x's both on the left and on the right. So what I want to do first is gather all those x's together. In order to gather all those x's together, I move the smaller one to join the larger one. It doesn't matter which one you move, but that's just the way I do it. So this 3x has no symbol in front of it. That means it's automatically a positive 3x, and the opposite of positive 3x would be a negative 3x. They cancel and go to 0, leaving with just 24 on the left-hand side. 5x minus 3x leaves me with 2x, and I bring down the minus 80. After that one step, it's similar to question 1. So what I should do next is get the 80 to the other side by adding it. That way the 2x piece is getting closer to being all by itself. So on the left-hand side, I have 24 plus 80, which is 104. And on the right-hand side, I still have this 2x. This means 2 times x. The opposite of multiplication is division, so I'm going to divide by 2 on both sides. And I go to my calculator, do 104 divided by 2, and get my answer. X is 52. So like I said, some of you may be fine with this because you've done it so often. Some of you may need to stick with me and go slower. If you want to fast forward and try some of these on your own, that's okay. Don't skip the whole thing though, because the equations start to change a little bit. All right, number 3. There are m's on both sides, so what I want to do is first gather all the letters, the variables, to the same side of the equal sign. So in order to do that, what I'm going to do is subtract the smaller 3m, so it cancels, and put it over here with the 7m. So 7 minus 3 makes it 4m. Bring down the minus 15 because I didn't do anything with it, and leave the plus 1, positive 1. I didn't do anything with that. Now I want to get m all by itself, so to get rid of the minus 15, the opposite of minus 15 would be to do plus 15. So I add 15 to both sides of my equal sign. Bring down the 4m, and then 1 plus 15 makes it 16. And to get the m by itself, this is 4 times m. The opposite of times is divide. So I divide both sides by 4, go to my calculator, and 16 divided by 4 is 4. Now sometimes you will be given a situation where you have to do a substitution before you can solve. So they're telling you here that y is equal to negative 18, but they give you the equation y plus 3x equals 12. So what we are supposed to do as math students is realize that I can substitute and replace the letter y with the number 15. Because if two things are equal, then you can put one value in place of the other and nothing should change. So we can do that with the letter y, replace it with the number negative 18, and the equation is still balanced. So the new equation looks like negative 18 instead of the y, and then still has plus 3x equals 12. So in order to solve for x, I want to get the x by itself. So I will get rid of the negative 18 by doing plus 18. 12 plus 18 is 30. Bring down the 3x. 12 plus 18, like I just said, is 30. So now we're supposed to get x alone. To separate the 3 away from the x, we will divide it out. And then you do 30 divided by 3. And we have our answer of x is 10. Sometimes the substitution is a little bit more involved than just a single number. So in this one, we see that y is equal to 2x. So all we're going to do is take our equation that says 2y plus 3x equals 63. We are going to replace just the y, take the y out, and replace it with a 2x. Everything else in the rest of the equation stays the same. Now we can just multiply 2 times 2x to simplify this a little bit. And then we can combine like terms. And now to solve it, the only step we have to worry about is dividing out the 7. So we go to our calculator and do 63 divided by 7. We get our answer of x equals 9. So the substitution sometimes is very helpful. And in a later unit, later lesson, we'll do much bigger equations, similar to number 6 here. We have 2x plus 10 equals 5y, and we are told that y can be replaced with, because it is equal to, x minus 4. So if I use this replacement of x minus 4 in place of where the y was, I now will have an equation that has all the same letters. So it becomes 2x plus 10 equals 5y, but instead of the y, I replace it with an x minus 4. So it's similar to number 2 up above where I have to distribute now. So I do 5 times x, which is 5x. And then I do 5 times negative 4. Remember, the subtraction sign here is telling me that it's a negative 4. So positive 5 times a negative 4 is negative 20. On the left-hand side, I still have 2x plus 10. So my choice is to subtract the 2x from both sides to combine it with the 5x. 5 minus 2 is 3. Look familiar? Not yet. Well, let's add 20 to both sides. And we get 30 equals 3x, just like up in number 2, which is coincidence. We had 30 equals 3x. So divide both sides by 3. And yahoo-wee, x is 10 again. Okay, so not every time that our equation has two variables are we going to be able to substitute and turn it all into the same letter. See, those last few examples, we could use substitution and take a situation that we can't solve because it had y and x and turn it into a situation that we can solve because they were all x's. Sometimes the equation will have more than one variable and we just have to rearrange what we have without using any substitutions. That's called a literal equation because there's literally still several letters in our equation. So I'll give you an example. This question says solve for a, and it's 3a plus 7b equals 11. We don't know any other information, so there's no substitutions that can happen here to make this something to solve like the above examples. So what we have to do is use the same skills and same steps, and we're just going to rearrange things a little bit. So if I want to solve for a, that means I get rid of anything that's not an a. The first thing to do is any adding or subtracting stuff. So I have to move whatever's being added or subtracted to the a term. In this case, it's that 7b. So we have to get the 7b to the other side of our equal sign. To do that, because it's a positive 7b to start with, the opposite would be the minus 7b to both sides. Now, I think these kinds of equations are actually a little bit easier. Even though they may look a little more confusing, it's actually less number work. Because once I subtract the 7b and it cancels, when I write it on the other side with the 11, because the 11 does not have a b, but the 7 does, they're not like terms. So they just get written next to each other, and there's nothing else to do with them. Now, to solve for a, I have to get rid of the 3. So I separate the 3 times a by using division of 3. Easiest way to write this is just to put one big division bar, like a fraction, and put the 3 on the bottom. And you're done. A equals 11 minus 7b all over 3. That's how you leave it, because they're not like terms. You cannot simplify it anymore. That's why sometimes it's a little easier, because you don't have to go to the calculator and worry about combining like terms and stuff like that. So let's try another one of those. This time we're going to solve for y. 2x plus 3y equals 18. If we want to solve for y, we do the plus or minus of stuff that's next to the y, that's near the y. So, sorry, that was a little confusing. Let me explain a little better. We're going to keep the y where it is and move the other stuff near it to the other side of the equal sign. And the first step in doing that would be moving the pieces that are added or subtracted. In this case, it's the 2x. Now, this is a positive 2x, so the opposite would be subtract 2x from both sides. Now, on the right-hand side, I have 18 minus 2x. Those are not like terms, so they just stay as 18 minus 2x. On the left-hand side, the reason why we did a minus 2x is so it would cancel. And I bring down the 3y. Now, in order to solve for y, that means get the y by itself. I get rid of the 3 by using division. And that's it. Once y is by itself, I have it solved for y. That's what it means to solve for y. Get y alone. Whatever jumbled fraction or mess I have, just leave it. That's the answer. As long as y is by itself, we are done with that question. All right, number 9. Solve for y again. In order to get the y alone, I want to do the opposite to get rid of the negative 3x. The opposite of negative 3x would be plus 3x. So I'm going to do plus 3x on both sides. Once I have that taken care of, I have 5y left over. And then I have 20 plus 3x. To get the y by itself, I divide out the 5 and just put this whole side divided by 5. And there's my answer. Once y is alone, 20 plus 3x over 5, then I have my answer. So why don't you pause, try a couple of these, and then turn it back on, and we'll see if your answers are correct. All right, so for the next one, I subtracted the 2mx to the other side. Please be careful to bring down the subtraction sign as a negative 2 in front of the y, because then you have to divide by negative 2 to get your final answer. Now this one could simplify because both parts of the numerator, the top, both of them have a 2 and there's a 2 in the bottom. So you could simplify this. In the first piece, 2 divided by negative 2 makes it negative 1b. And then the second piece, negative 2 divided by negative 2 would be a positive mx. So both answers are equivalent and either one would be acceptable. So pause again, do number 11, and then we'll see how you did. Okay, bam. Distribute the 3. Make sure you keep the minus r as a minus 3r. You're solving for w. It's important to know which letter you want to have all by itself. So you're solving for w. So I add the 3r over, divide by 3 to get w by itself. All right, one more. Pause, try it, then come back. And we're back. So I subtracted the 3a from both sides, then divided by 3. This one we cannot simplify because the 3 that's in the denominator does not divide evenly into all parts of the numerator. So that's how we leave it. Now, let's apply the same principles to the graph we were doing the other day, the inequalities. The only thing that's different here is when you divide or multiply by a negative number, you must switch the direction of the inequality sign. So what I mean by that is your less than symbol would turn into a greater than symbol. Or if it's pointing to the left and you have to divide by a negative number to get x alone, when you rewrite it, you point it to the right. So if I have negative x, or negative, let's put negative 3x. I just want to show you an example here. If I have negative 3x is less than 9, I would have to divide by negative 3 in order to get x alone. So since I am dividing by a negative number, the inequality sign here switches and points to the other opposite direction. It doesn't affect the numbers at all, but I have to make sure I switch it, okay? Because otherwise the numbers won't work back in the original equation. So let's practice some inequalities, and we just have to be on the lookout for that rule. And if it pops up, we have to do it. If it doesn't pop up, then it's the same as the other page where it's just regular equation solving stuff. And then we can practice some graphs. So I would subtract 2 from both sides. Get 5x is less than 15. Then I would divide both sides by 5. And have x is less than 3. So on the graphs we did 3, 4, 5, 6, 3, 2, 1, 0. Circle around the 3, but open because it cannot be equal to. X is smaller than the 3, so it goes down. Now, what numbers satisfy this problem? I can pick any numbers that are smaller than 3. So it says list 5 numbers, 0, 1, 2, that's 3 numbers. 3 does not work, so I can use 2.5 because it's still smaller than 3. 2.75 is still smaller than 3. There's my 5 numbers. They don't have to be full whole numbers. It's okay to use decimals. So for our next one, we're going to do the same kind of thing. We want to get x by itself. So in order to make that happen, I'm going to subtract the 9 from both sides. And then do -3 minus 9 more, which is technically the same thing as saying -3 plus a -9. Calculator, brain, whatever works. That's -12 is greater than 4x. To get x alone, we're going to divide out the 4. The 4 is a positive number, so I do not need to worry about switching my sign. Even though the 12 is a negative, I'm not dividing by the -12. I'm dividing by the +4. So my inequality symbol stays the way it was. Now, when I rewrite it, I want to keep everything where it's located. And what I mean by that is that my number, -12 divided by 4 is -3. That's going to be on the left side of my inequality sign. My inequality sign stays facing the same way it was. The 4's cancel out, and the x was on the right. I don't want to switch sides. I want to keep everything the way it was so everything stays accurate. So now we graph it. X has to be smaller than the -3 but not equal to. So I put some numbers on my number line. A circle around the -3. I leave it open because it cannot be equal to. And x is smaller than the -3, so I go down to the right. So it says list 5 numbers that satisfy each problem above. The largest possible integer, not number, because I'm talking about integers. Integers have no decimals. The largest possible integer that could work here is the -4. And then the next largest, counting down, -5, -6, -7. Those are all integers because there's no decimals. Now, if I were to ask you what's the largest number that satisfies this condition, I wouldn't be able to tell you because it would be -3.000000001, but then somebody else could do that and just say one more zero. So there is no largest number that works because it cannot be exactly equal to -3. And the smallest number would be -infinity, so that doesn't count either. But the integers that are listed with no decimals just count down after -3 and below. 2 more, then we're done. If you feel like you know what you're doing, that's fine, but you have to make sure you remember that when you divide by a negative, you change the direction of the inequality sign. And here's an example that's going to show you exactly what I mean. 6 divided by -9x is -3x. The subtraction of 27 means to bring down a -27. Now here, to get x alone, I have to divide by -3. When I divide by a negative, the inequality sign switches and points to the opposite direction. The negative divided by a negative is positive. 27 divided by 3 is 9. So when I graph it, I still do not have or greater than or equal to. It's just greater than. Circle around the 9. X is bigger than the 9, so the arrow goes up. The smallest integer, non-decimal number, the smallest integer that makes this true has to be an integer bigger than 9. So it's 10, 11, 12, 13, 14. There's my 5 numbers at work. The last one. Let's use purple. I want to subtract the 12 from both sides. Divide by 5. Now I'm dividing by a positive number. -20 divided by 5 is -4. Since I'm dividing by a positive number, my inequality sign stays the way it was. X has to be smaller than -4. Smaller than or equal to. So we can fill in the dot this time. X is smaller than or equal to, shade down. Numbers that make this work. This time, the smallest integer that makes it work is the -4 itself, or smaller. All right, guys, done. 25 minutes. Fantastic. Have a great day.